Thank you again for joining our linked data course. We are now approaching the end of the first week. I hope you're enjoying it so far. 12 of you have already finished the course, which I think is fantastic. Congratulations. All people who will finish the course are entitled to get a statement of participation, which you can use as evidence for completing the course successfully. So in this short video, we're gonna give a summary of the activities that we have seen, point to some comments that some of you have made in the discussion forum, and then walk you through some of the issues some of you have raised in step 1.10 in the exercise that we have proposed for you to do this week. Let me just first introduce Chris. He's a facilitator on the course. Chris is a research fellow at the University of Southampton, and he is in charge of developing a curriculum for data science in the European Data Science Academy European project. Chris is going to do this short video with me, and he's going to walk you through the exercise in step 1.10. Of this week's course.
Yeah, so hello everyone. I'd just like to say thanks for joining the course. I've been looking at the comments a lot, and you've probably seen me in the comment sections a bit. We've been really impressed with the high level of motivation that we've seen among people willing to take on board the new information and then actually go on and apply this in the exercise later on in the week and in the discussions about the sort of implications of linked data. So it's been really fascinating for me and for everyone else here to read those conversations and see what you're talking about, what examples of linked data you're going off and finding online. And it's been really good to sort of hear your first experiences using linked data. So that's been really good. We've had some really varied examples of where you are finding linked data in use.
And this helps us, having these examples mentioned and discussed helps us a lot in developing the course further, because it gives us an overview of how people all over the world understand linked data and the range of applications it could have. So thank you very much again for all those discussions and for the comments.
Yes, we've had over 300 of you posting comments, so that's been great to see, and they've been coming in from all over the world. So we picked a couple out that we would like to talk about further, so I'm going to ask Elena some questions. The first one comes from Dave in step 1.6, and he was asking about whether OWL's lower than expected take-up is because it didn't quite meet its requirements. And I'll put in the other question here as well. It's related to one from Paul in the same step, about whether this could be due to the rise of big data, and whether that's affected the take-up of OWL.
Thanks for that, Chris and Dave and Paul, for raising these issues. So maybe I start with the first one. The first question referred to the adoption of the web ontology language. And I think that the short answer to that question is no. OWL was meant to address a slightly different set of scenarios than perhaps RDF, Sparkle, RDFS, or SCOS, which are some of the technologies that you have learned about briefly this week. So some of you might remember the technology stack we have introduced, that layered cake. So one way to look at that technology stack is that the technologies that are placed at the lower end of the stack are applicable in a wider range of settings, whereas the technologies and topics that you see at the higher end of the stack, they are much more advanced, or perhaps they address much more specific scenarios. And to make this clearer perhaps, something like the Resource Description Framework Language, or RDFS, they can be applied in pretty much any scenario in which you need to do data management and integration, where you perhaps have a schema that will change a lot, or you perhaps don't know the schema in advance and you still want to integrate data in your application from different sources. Whereas when you go to OWL, OWL is a much more sophisticated, much more richer knowledge representation, and it is meant for those scenarios in which you want to encode a very rich schema. Now, this encoding exercise is costly. It takes time to create an OWL schema, much more time, many more resources, a higher level of expertise than to do so, say, for SCOS or for RDFS schemas. And as such, the range of scenarios in which an OWL representation pays off is much narrower than, say, for RDFS and for more lightweight formalism. So it's not a matter of being less adopted. It's not a matter of not meeting the requirements. I think because it meets the requirements it was intended for, it addresses by design a very specific type of application scenarios, which is smaller than perhaps for RDF or for Sparkle. So going to the second question, this was about big data and the relationship between OWL and big data. So I think the relationship between semantic web technologies and big data in general is not yet fully understood. But the general view seems to be that semantic technologies stand for a particular approach in data management and data integration that is rather top-down. So you start with a schema, you represent your knowledge, and then based on that model of the world, you process, manage, organize your database. Whereas in big data, the approach seems to be more top-down. You have large amounts of data, and then you infer structures, patterns from that data by analyzing it. So in a way, the two complement each other very well. So you could imagine that patterns or classes or clusters that are learned on top of big data are represented then in RDFS or OWL in order to be easier to integrate with other sources.
Okay, so we wanted to talk a bit more about the exercise step in 1.10, which was the step that asked you to use RDF in the interactive exercise. We're aware that a few of you had some issues with this and found it quite challenging, but we would encourage you to sort of revisit it, take your time with it and go back through the material, take it question by question and check. So once you've done question one, check your answers with the model answers that we've produced, just to make sure you're on the right track, and start looking at where maybe you're going wrong. And we'll be there in the comments to help out, as well as your fellow learners.
Yeah, so I think we're aware of the fact that for some of you who are perhaps really new to this area, this can be a really steep learning curve. There's lots of syntax to be taken in, but it's like with many technical concepts in programming languages, you really have to go and try it. And you will learn the syntax only once you have tried and failed many times to write those queries and use the different RDF syntaxes that have been presented in the course. And this is the only way for you to truly learn the syntaxes and the languages and be able to use them for yourself in your own examples.
Sure. So in order to help with this and just to give you somewhere to start from, if you looked at the exercise and just had no idea what to do at all, I'm going to do a quick walkthrough of how you could approach the first question in the exercise now. So if I just switch to the laptop. So the first thing that you will see when you load up the exercise is this screen, okay? And you have a box at the top here which lets you change the RDF syntax, okay? So that by default is turtle, and it presents the RDF below in turtle by default. And the first question asks you to change this to n triples, okay? So the first thing we're going to do is tell it to expect n triples, okay? Now, now we're ready to actually start changing the syntax into n triples format. One of the things we noticed in some of the comments was there was a bit of confusion about the base and the prefix statements. Okay, these are not RDF triples themselves. You don't convert, say, this line into an n triple. Okay, this is used in Turtle as an abbreviation within the other triples, so to make the RDF triples simpler and easier to read.
So for some of those of you who are familiar with XML, this is a header that you typically see in XML as well. So there are those namespaces which have prefixes. So vocab is a prefix, RDFS is a prefix, FOF is a prefix. Some of these prefixes are defined by the semantic web stack. So RDFS is a prefix that is predefined. It defines the concepts of RDF schema. FOF and vocab are defined by users of semantic web technology. So FOF is something that you have learned in the course today. It is a vocabulary that is widely used in the community to model information about people and organizations, whereas vocab is a vocabulary we have created in this course. So you can use all these types of resources and define where they are using the prefix line there. Base refers to the actual document in which you are writing, in which you're changing the syntax.
Right, so if we look at the first actual triple that we have here, it's this line here. So it says that research project is a subclass of group. Okay, so how do we go about changing that from Turtle to n triples? Well, we see here at the beginning that it's using the vocab prefix, which is defined up here at the top. Okay, so we literally take that, and for easy use we'll do this underneath so that we can see the original and the new. And we use that prefix literally as a prefix. Okay, so we then take research project and we put that on the end. Okay, so we see the vocab prefix is now the prefix to research project. Okay, and that is the subject of our first RDF triple done. Okay, so we now move on to the predicate, which is RDFS subclass of. Okay, and you'll notice that RDFS again is defined as a prefix up here. So we take that prefix, we put it there, and the thing we want to put on the end is subclass of. Okay.
So what we're doing basically for each of these resources, research project, subclass of, group and so on, is we're resolving them. Resolving means we're replacing the prefixes with the actual addresses, with the actual identifiers.
Okay, and finally for the object, we have FOF group. So this is the prefix in this case. And we want to add on group to the end. Okay.
Mm-hmm.
So this gives us our first triple in n triples format. What I'm going to do now is I'm going to skip consortium member, so you would follow the exact same approach for doing that. And I'm going to move on to converting some of the triples that are about Barry. Okay, so you've seen Barry in the videos in the course so far. So to start off with, here with the angle brackets around Barry, this tells us that we have to use the base abbreviation that's defined at the top. Okay, so this is the URL containing Euclid projects /examples. Okay, so we take that entire thing, and we add array to the end of it. Okay. The first predicate in this case is the predicate A. Okay, and if you recall from step 1.8, A is special Turtle shorthand for the type relationship. Thank you.
In RDF.
In RDF, yeah.
So this is one of the most popular, widely used relationships that is defined already in RDF. So instead of saying A, which is meant to improve the readability of the code, we are now replacing it with something that the machines will understand. And just like in the other examples, we will probably have to add the prefix.
Yes.
And then instead of writing A, like in the appending it at the end of the for URI, we are going to write the actual name of the predicate in the RDF language, which is type. If you don't know the namespace, one way to do it in general is to have a look at the official documents at the W3C, the World Wide Web Consortium, that define them. Or just a shortcut, in this case, if you would Google for something like XMLNS, which stands for XML namespace, and then semicolon RDF, then most likely you will find the namespace that you need to type in. In this case, I guess we have already specified it in step 1.8, right?
Yes, so if you head to 1.8, we have an example here where we use a inner turtle triple, and we then expand that later on here. So this is what A is an abbreviation for.
Mm-hmm.
Okay. So if we head back to the exercise, so that is now the predicate that says Barry is a type, and now we need the object to say what he is a type of. And that is here, so it's Photh person. So if we get the Photh prefix again, and put that here, and then it is slash person at the end. Okay, so this now says Barry is a type person.
Mm-hmm.
Okay. We will do the next triple now to say what his given name is, so that we know that his name is actually Barry. And recall that if there's a semicolon at the end of a triple, this means that the subject is carrying over. So we're using the same subject, so Barry, and giving him a new relationship, which is his given name. Okay, so we can literally just copy the subject as it was again. We need to put a dot here. Yes, we do. So now saying Barry, and again the prefix is Photh. And the relationship is given name. Okay. Now for the object, we go here and we see Barry in quotation marks. There were a couple of comments on the exercise where people weren't too sure what to do with this, and they were trying to expand that to a URI for the name Barry. Okay, this isn't necessary because what we're defining here is a literal. We're just saying this is a string of characters for the word Barry. Okay, his name is Barry.
So the difference perhaps between the subject and the object of this triple is that in the first case, Barry is a identifier. It is expanded using the base namespace, but it doesn't actually have a meaning for the machine. So we could have just as well used, instead of Barry there, we could have used whatever identifier. We could have said 1, 2, 3, 4. It would have been exactly the same thing for the IDF document. The second Barry, the one in quotation marks, is important because that is actually the name, the given name of that resource. Yeah. So in the first case, the assumption is, and the official specification says, that there is no implicit semantic. You use it there because it's easier for a human to read and to understand what that resource is referring to, but it doesn't actually have to mean anything, and we could use whatever identifier we want. In the second case, that's actually data. So we're saying the given name is Barry and not a different one.
Sure. So then to do the final triple for Barry's family name, you would essentially do exactly the same as this line, but you would be using the family name relationship rather than given name here, and obviously your string literal here would be Norton rather than Barry. Okay, and then you would follow this same process again for the Euclid triples here. So again, you would have one with a label, which is a string, and another one for the consortium member. So this is saying Euclid has a consortium member, which is Barry, and that refers back to your triples about Barry. Okay, so hopefully that will give you a starting point for this exercise. If you were a little bit confused when you first looked at it, this will give you somewhere to build from. Once you've converted everything to n triples, you can remove all this turtle here. Well, once you do that, you can check that everything is sort of okay. If you scroll down to the bottom, and run the query. So if we take the query from the exercise,
There you go.
and put that in there, and click on submit, we get a result down here to say that Barry has been found as an agent, which means that our n triples are correctly written. You will get a little bit more when you've done this with all the triples, because you should get Euclid return there as well, but we haven't done everything in this video. Okay, so this tells us that we've done it all correctly. There aren't any errors in our code. If, for example, we left off one of these full stops at the end, the dots, as I have done previously, and then click submit again, we get an error, okay? And this tells us that on the fifth line, column 134, so somewhere towards the right-hand side, there is an error, and you can sort of read this to get an idea of what it is. So unexpected EOL, which stands for end of line. So that implies the line sort of ended without something that it
In
needs
an
to
unexpected
in
way.
an unexpected way.
For the syntax validate, yes.
Yeah. So if we add that back in, click submit, and we get a result again. So we've corrected that error. Okay. So for the rest of the exercise, you can then go on and carry on using the n triples that you've written, or you can copy back in the original turtle that was presented, and you can use that for the future questions in the exercise if you want. The turtle is just sort of a little bit more user-friendly, I guess, to carry out the rest of the questions, but it's up to you. The model answers we've provided are in n triples because they sort of assume that you will follow it through, but it's your choice to make. And if you do decide to do it in Turtle, then it's an extra step when you're looking at the answers. You can convert the answers from N triples to Turtle to check you've done it right.
Something to look forward to. Okay.
Okay.
So I guess this was all for this week.
Yes, we will see you next week. I'll be in the comment section some more, replying and helping out. If you do have any questions or anything you want us to address on next week's video, then do leave us a comment. We have a team who are reading them all.
Yeah, so we're reading them all, and we'd encourage you to keep posting, raise whatever questions you have about the exercises, about the course, about things you think we should cover, and also try to help one another. So this is for us an opportunity to discuss and to raise the most important questions we have perhaps not thought of in the course, and we of course we're gonna try to answer as many as you can, of course, but we would appreciate and encourage you to go on and apply some of the knowledge that you have gained already this week and answer some of the questions of your peers. With that being said, I guess we're going to see each other next week. Bye-bye.
Thanks.